For number 13, it's a quadratic, it's set equal to 0. And let's see, everything's even, so I could divide everything by 2 and get m squared minus 8m plus 4 is equal to 0. Well, this stinks because this isn't factorable. So to solve this, I would have to actually use the quadratic formula or complete the square on it. I'm gonna use the quadratic formula. So m is going to be equal to, and I tell you what, I'll write it over here. Normally it would be x, but all my variables are m. So m will be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. And let's see. So m is going to be equal to negative b, so negative 8 plus or minus the square root of b squared, so negative 8 quantity squared, so that because the negative is going to go away in this case. So b squared minus 4a, which is 1 because it's 1m squared, and times c, 4 all over 2a, so 2 times 1. Now, it doesn't matter if I use the numbers a, b, and c from the first form, where a is 2, b is negative 16, and c is 8, or the simplified form that I came up with. It won't matter, you'll get the same result. So to make my number smaller, I went with the second version. And let's see, to clean this up, 2 negatives make a positive. Negative 8 quantity squared is 64 minus 16 all over 2, which is equal to 8 plus or minus the square root. 64 minus 16 is 64, 54, 50, 48. Just how I do things in my head. And let's see. I could simplify this root 48, but what we're looking for, they want to know the sum of all values of m. Well, m is equal to 2 distinct values here. So let's say m1 is equal to, when I say 8 plus root 48, all over 2. And m2 is going to be, when I use the minus sign, 8 minus root 48, all over 2. And when I add those together, which is what they're looking for, well, the 8 plus 8 is going to give me 16. Root 48 plus the negative root 48, those are going to cancel since I'm adding over the common denominator. And so the sum of the two answers is 8. And so I want D. All right, now it took decent amount of work to do all that. I'm going to go through this one more time, just using the quadratic formula. I wouldn't recommend actually doing it on the test, but just as a background to this, if we just look at the quadratic formula, I could have just written, so one solution is negative b plus the discriminant, square root of the discriminant, all over 2a. m2 is going to be negative b minus the square root of the discriminant. Let me make that look more like a 4. All over 2a. And if I add those two, regardless of what a, b, and c are, well, again, the plus square root of the discriminant, adding the negative square root of the discriminant, these are going to cancel. Negative b plus a negative b is negative 2b over the 2a. The 2's will cancel, leaving me negative b over a. Now, who's going to, people don't like to memorize the quadratic formula in the first place and then to add one more thing into it. But if you happen to know, the sum of the two answers will always turn out to be negative b over a. So if I just kept it right from the beginning, I could have just said, oh, well, first solution plus the second solution is going to be negative. The b value is negative 16 over a, which was 2. 2 negatives make a positive, and 16 over 2 is 8. And I would be done if I just, happen to have that formula memorized.